This lesson, we're tasked with factoring trinomials of the form x squared plus bx plus c. And in order to get you to understand this, we're going to look at using the FOIL algorithm to expand a product of two binomials to get a trinomial of the form x squared plus bx plus c. What factoring is going backwards from this trinomial to these two binomials. So if you think about what factoring is, it's the reverse of multiplying. So if you're given 2 times 3 and you're asked to multiply it to get 6, when we say factor, we're saying what can multiply to get 6. So what multiplies to get this trinomial? Now, with the number 6, there's 2 sets of factors, 2 and 3, that multiply by each other to get 6. You could also say 1 times 6 is 6. Now with trinomials, if they are factorable, there will only be 2 unique binomials that multiply by one another to get that trinomial. So in order to understand what the process is of factoring this trinomial to be these two, I want to reinvestigate foiling. Because if we understand how to FOIL two binomials, to expand them to get that trinomial, that will help us to go backwards. So remember, the FOIL algorithm is first times first gets us that x squared. Then there's the outers and inners. The outer product would be the x times the positive 5, which makes a plus 5x. And the inner product is the positive 3 and the x, which makes a plus 3x. Notice the 5x and the 3x add to be that middle term, 8x right there. And the last times the last, the 3 times 5 gets us the 15. So that's just kind of revisiting how you get from a binomial to a trinomial. So now if we consider that we don't know what these two binomials are that multiplies to get that trinomial, we could begin guessing. We could, let me get rid of this here so I have a little more space. We could say we know it's going to be a binomial times a binomial to get that. And to get that x squared, we know the first times the first has to get us that x squared. So we could have an x times an x, right? Seems like we're almost there. Well, this number 15, there are more than one set of factors that multiply to get 15. There's 1 and 15, and there's 3 and 5. Well, let's say again, we didn't know this. Maybe we would try arbitrarily by guessing 1 and 15. Well, the first times the first gets us that x squared. The last times the last gets us that 15. Things are looking good. But when we look at our outer product, an x and a 15 make a 15x, and our inner product, the 1 and the x, make an x, those would add to be 16x, not be 8x. So they would add to be 16x. So here's kind of the key for this. When we see an addition in this last term there, it means we want our outer and inner products, that outer product and that inner product, to add to be that amount. So we can in effect look at the product, the factors that have a product of 15, 1 and 15, 3 and 5. We can see 3 and 5 multiply to be 15, and they add to be 8. So that tells us whenever we're trying to get to the two binomials, we're going to be using these two, not these two. So the way we'll set it up, again, it's as if we don't know that those are the binomials that multiply to be that. We will set up with x and x, because that multiplies to be x squared. We'll set up with 3 and 5, because those multiply to get 15. And here our outers and our inners make a 5x and a 3x, and those add to be 8x. 5x and 3x add to be 8x. They have to add to be specifically positive 8x, so we need that to be a positive 5x and a positive 3x. For that to be a positive 5x, we need that 5 to be positive. For that 3x to be positive, we need that 3 to be positive. And then it works. This is the factored form of that trinomial. So, if we look at this second example that I have here, if we again re-examine foiling, how we get from the binomials to the trinomial, we see our first times our first gets us that product of x squared. Our last times our last, the negative 4 and the negative 6, multiply to get us that positive 24. If we look at our outers and our inners, our outer product, an x and a negative 6 make a negative 6x, and our inners, a negative 4 and an x make a negative 4x. When we combine those, we do get that middle term of negative 10x. So, again, if we have this trinomial, and we want to factor to get these two binomials, we have to look at what multiplies to be 24, so we see what goes in the last spot in the binomials, and we want those to add to be 10. So if we look at the number 24, 24 can be obtained by taking 1 times 24, 2 times 12, 3 times 8, or 4 times 6. Again, because this is positive, it means the two factors have to have the same sign. They either both have to be negative or both have to be positive. So I kind of ignore whether or not they're positive or negative to begin with, and I just look for factors of 24 that add to be 10. Those two factors add to be 25. Those two factors add to be 14. Those two factors add to be 11. These two factors add to be 10. So that tells me I'm going to be using 4 and 6 if I want to factor this. So if I want to factor this to be this, I start by writing, I know that I have a binomial times a binomial. To get my x squared, I have an x and an x, because x times x is x squared. I've identified that I know I'm going to be using 4 and 6. 4 and 6. So there's going to, my last times my last, that's going to give me my 24. And now I want them to add to be negative 10. So that 4x, which is the inner, that 6x, which is the outer, they both have to be negative. Negative 6x and negative 4x combine to be negative 10x. And for that 4x to be negative, the 4 has to be subtracted. For that 6x to be negative, that 6 has to be subtracted. That will make those two, negative 6 and negative 4x, that combine to be negative 10x. And look, negative 4 times negative 6 makes positive 24. I realize it seems a bit strange to think about it backwards when we have the answer right there. But I want you to see the process. The first part of this lesson, we're going to be factoring x squared plus bx plus c, where we have plus c. The second part of the notes, we're going to change that c to be a minus c. So we'll see x squared plus bx minus c. And this plus, in both cases, could be plus b or it could be minus b. Plus bx minus bx. That could happen in either. But really what leads us to identifying the strategy we're going to be using is whether it's minus c or whether it's plus c.